Bismillahir Rahmanir Rahim. Assalamu alaikum. Dear student, this is me, Ihtishamul Haq. Today we are discussing about the third lesson of the week. As we learned in our previous lesson that there are pure substances that might be elements, molecules, or compound. Then we discussed in our previous lesson about the physical change. So if you look over here, you can see that a solid water molecule converts into liquid and the liquid is going to convert into gaseous state. We call this one a physical change. Why we call it as a physical change? Because as you know that when water molecules are converting from solid into liquid, look, the chemical formula remains same. Over here it is H2O. When it converts into liquid, it has the same chemical formula, that is H2O. When the same liquid converts into gaseous state, it has the same chemical formula, that is H2O. So it means that in physical state, the identity of a substance will never change. Now the next topic is related to chemical properties. In a chemical properties, the identity of a substance will change. So if you look into the definition over here, a change in which one or more substances are converted into different substances is called a chemical change. Let me give you some examples over here. If you look into this one, you can see that a fresh and green leaf now convert into dry and a brown leaf now. So it means that in this case, some sort of chemical changes takes place over here now. So if we are moving towards the next example, you can see over here. Okay, let me show you this one. The cross sign over here and the reversible process over here now. Dear student, look, a chemical reaction, like in case of this one, a fresh and green leaf is converting into dry and brown leaf. It is an irreversible process, means it will not come back to its original form, that is fresh and green leaf. So this is a chemical reaction going to take place in the leaf now. But if I'm going to discuss some more examples, like over here, like we have a one pencil over here. When we are going to break the pencil, look, we just cut the pencils over here. It is the same pencil at the end. We are not getting something new. Over here there's a one pencil, and in this case there's a broken pencil over here. The identity of substance is the same thing. It is the same sample. And if you look over here, it's a butter. After some time it melts, so it means if we are going to freeze it again give the same solid bed at the end. So we can say that it is a physical change now. While in chemical change, look, when we have a piece of wood, when it burns, at the end we are not going to get the wood again. We are going to get ashes at the end. We are getting something new, and we can't convert the ashes into wood again. So it is irreversible process now. So this is known as a chemical change. We are getting something new at the end. Same in case of the egg over here. When we are going to boil an egg, it gives us this sort of egg at the end. So we can't convert the egg into this shape again. So it means that a chemical reaction takes place in this case right now. So now, just dear student, if you look into this one, when an ice converts into water or liquid state, look, the same water molecules are here, the same formula H2O, only the molecules are a little bit far apart from each other. We can call this one a physical change. So if we are moving towards the next part, that is related to the reactions now. When a reaction takes place, a reactant converts into a product. What does it mean by the reactant and the product? These are the two new terms for you people now. The reactants are the substances that react in a chemical change, while the products are the substances that formed at the end now. For example, when a carbon, it reacts with oxygen, it gives us carbon dioxide. So now if you look into this arrow, to the left side of this arrow, these are known as reactants, while to the right side of this arrow, we can call it a product. So some new things are formed at the end. We can call it a chemical process. Now, how do you understand that a chemical reaction takes place now? For example, there are many, you're going to a laboratory, you're doing different sorts of experiments. So how do you understand that a chemical reaction is going to take place? Now, there are many methods in order to understand it, but we will discuss some of the methods over here now. The very first method is sort of, you can say that bubbles formation takes place. Look in this experiment, if you look into this experiment, when acetic acid in vinegar and sodium hydrogen carbonates or baking soda are mixed together. Now these are the chemicals, acid and some sort of bases. When they are going to mix together, the solution bubbles as a carbon dioxide forms. So when we mix together, in the beaker we can easily see the bubbles formation over there. So we can say, we can predict that a chemical reaction is going on. So the first method, in order to understand the chemical reaction is going to take place, is the formation of bubble. The second method, a precipitate is formed. Now look, when solution of sodium sulfite, H2S is the chemical formula of sodium sulfite, when reacts with cadmium nitrate. So what will happen? A cadmium sulfite is formed. A cadmium sulfite is a yellow in color and it is a precipitate. So you can see that the precipitate will form on the top of the solution, or it will settle down if they are more dense. So these are some very tiny solid particles, the precipitate. Now the third method in order to understand the chemical change or the chemical reaction is a release of heat or light. Now when aluminium reacts with iron 3 oxide in a clay pot, energy is released. You can see the sparking of the iron oxides over there. You can say that a chemical reaction is going to take place over there. Now the fourth part that deals with the evidence of chemical changes, when phenolphthalein is a chemical. A phenolphthalein is a chemical, is added to ammonia, it dissolves in water, a color change from colorless to pink occurs. Now initially ammonia is colorless. When phenolphthalein is added, the change in color takes place. So we can say that a chemical change is going to take place in the process. Now dear student, we discussed some of the evidences over here related to the chemical changes. Now look over here. Now when as I told you, in an example we discussed that when a wood burned, it gives us ashes at the end. Now what does it mean? Can we say that the mass is completely destroyed, or can we say that the energy is completely destroyed, or we released more energy? The answer is that energy and mass is always conserved. What does it mean now? In a chemical reaction, the mass or energy is neither created nor destroyed, but it is changed from one state into another state. We can say this one as a law of conservation of mass or law of conservation of energy. So we discussed all these things. We discussed about the matter, and we said that the matters are the pure substances and also mixtures. The pure substances are further classified into elements and compounds. Now we will discuss about mixtures now. Now dear student, when we are discussing about the mixtures, we must understand that a mixture is a blend of two or more kind of matter, each of which retain its own identity and property. Means when we mixed it, they will not change its properties. The properties will remain the same within the mixture. So what are the two important properties of mixture now? In mixture, the matters are mixed together physically, like stirring, like shaking, etc. And they can be easily separated also. So mixtures, I told you, it is a blend of two or more matter, and each of these matter retain its identity within a mixture, and they are physically mixed together. And what's the important part? They can be separated usually now. Now there are two types of mixture. Number one, homogeneous mixture. Number two, heterogeneous mixture. Now what is the difference between homogeneous and heterogeneous mixture? Look into this one. We have an example over here, two beakers with the same amount of water over here now. As you know that water is a universal solvent. Now in this water, the sugar molecules are added into this water and they are physically mixed together by stirring. After some time, if you look into this water very carefully, you can't see the particles of sugar anymore. It means that the whole sugar is mixed in this water completely now, uniformly distributed. This sort of mixture is known as homogeneous mixture. While in another case, the same water is being added by the molecules of scent, the scent molecules, are the scent particles. When they are added into this water, when they are stirred for a time being, they disperse in the water. When you will keep it, after some time, the scent molecules settle down. The scent molecules settle down. They are not uniformly mixed with the solvent, with the water. Such a kind of mixture is known as um, heterogeneous mixture. Now, dear student, a pure substance, now we discussed, look, two important parts. The pure substance, they are divided into compounds and elements. The mixtures, they are divided into homogeneous mixture and heterogeneous mixture. Now, dear student, in laboratory, when we are using all these chemicals, we must understand that the chemicals that are used in different sorts of pharmaceutical products are different sorts of, you can say that other laboratories or industries. When we are using these chemicals, it should be pure chemicals that we have to use now. Now, dear student, look, all these things we studied over here, the examples of mixtures, that is the homogeneous mixtures, are in front of you. You can pause it over here and you can go through it. And if you are facing any sort of trouble regarding this one, you can ask from me, and we will discuss the rest of the topic in the Zoom session, the Zoom live session. Also, you can discuss your ideas, your doubts in Zoom discussion, Schoology discussion forum. Thank you very much, dear student.